Hello, this is the Chapter 9 Rainbow Review. I'm not going to do every single problem, but I'll do maybe one from each section or so, see how it goes. Alright, for pink, I wish it was pink, but it's not. Write in radical form and evaluate. So radical form is basically a root instead of a power. I'm going to do, well, 81 to the 1/2 is kind of a simple one, because 1/2 is just square root. And it's just 9. Okay, so 16 to the 5/4 is trickier. So I tend to do the root first. So I'm going to do 4th root of 16. So that's the 4. And then to the 5th power. And I know the 4th root of 16 is 2. So then I have 2 to the 5th, which is 32. Exponential form, basically it's whatever's on the inside, so 2x in this case, and then it's exponent over root, so 5/4. Radical form, so first we can kind of distribute here, so 32 to the 2/5, and then n to the 2 times 2/5, which is 4/5. 32 to the 2/5, well, 5th root of 32 is 2. 2 squared is 4. So we have 4n to the 4/5, or 4, let's see, we can do it this way, n to the 4th, 5th root. You could honestly also just leave it as keep the 32n squared and do that squared 5th root as a non-simplified version. That's fine as well. When we solve for x, so x cubed is -8. Basically, what cubed equals -8? Or you can do both sides to the 1/3 power. So x equals -2. So weird looking equal sign, but oh well. If we do x to the 6th equals 64, well, we'll do the 1/6 power, and x is 2, because 2 to the 6th is 64, but x can also be -2, because -2 in parentheses to the 6th is also 64. I'll do this one too. Basically to the 1/4 power, or you're thinking what to the 4th power equals -81, and there's no solution for this. Because if you think about 4 numbers being multiplied together, if they're positive, you'll end up with positive. Oops. And if they're negative, you'll end up with a positive times a positive. So it's impossible to multiply 4 numbers and get a negative. Now we have the exponent rules. I'll do a couple of these. Maybe I'll do these two. Again, the key should be in the folder, so you should find the answers to all of them. I'm just not going to do every single one. Okay, so it has, losing my words, it has a fraction. So I'm going to keep a fraction bar there. First I'm going to look at the 2 and the 4. 2/4 simplifies to be 1/2. And then a cubed and a to the 5th. 3 minus 5 is -2. So a squared is on the bottom. This is like b to the 1st. So looking at the b's, -4 minus 1 is -5. So we get b to the 5th on the bottom. So 1/2a squared b to the 5th. Again, there's slightly different ways to think of this, but I'm just going to show you the one that makes sense to me. Looking at this one here, first I'm going to deal with this part. I'm going to distribute that -2. So we have negative 3 to the negative second. We have p, negative 4 times negative 2, so p to the 8th, and q to the negative second, and we still have 7p to the negative first, q to the 9th. Okay, I see some, let's see how we're going to do this. Yeah, we're going to leave the negative 3 to the negative second for now. So negative 3 to the negative second. For the p's, 8 plus negative 1, we have p to the 7th. For the q's, negative 2 plus 9 is 7. So q to the 7th, then we have a 7. So negative 3 to the negative second is 1 over negative 3 squared. And then we have p to the 7th, q to the 7th, and 7. So 1 over negative 3 squared is 1/9. Multiply that by 7. We have 7 over 9, p to the 7th, q to the 7th. You could write this as 7p to the 7th, q to the 7th over 9 also, if you wanted to. All right, gold. Exponential form. So let's see. Let's do these two, just because. So basically our base is always right here. Exponent is here. So to rewrite it, it's 4 to the negative third equals 1 over 64. And again, to tell if you're right, they should always be true statements. So 4 to the negative third power actually does equal 1 over 64. And you got variables, there's not really a way to tell if it's true. For log base b of x equals y, b is our base, x is our exponent, y is our exponent, so b to the y equals x. Now log form. So for this one here, log, our base is right here, 2, our exponent always goes over here, so 1 over 256 is here. And then honestly, when I look back at it, I think, okay, 2 to the negative 8th, 1 over 256, good. I usually kind of check it going the other way. Let's do this one. So log, is our base, our 3 goes over here, so 125. And then I'll look at it and think, is this true? Yep, 5 cubed, 125, just like we wanted. Now solving for x. So the tricky part here, when there's no base, it's a 10. So I can rewrite this equation as log base 10 of x equals 4. And then I'm going to rewrite it in exponential form to solve. So 10 to the 4th equals x. So a 10 to the 4th is just 4 zeros. So x equals 10,000. Let's do this one. Let's do this last one. So rewriting it, we'll have 3 to the x equals 1/9. Now, 3 to what power equals 1 over 9? Well, if I think of this as 3 to the x equals 1 over 3 squared, so 3 to the x equals 3 to the negative second. These have to be the same, so x must be negative 2. Now we have log properties. So let's do both of them. Why not? You can fast forward if you don't want to hear it, or not listen to this at all. Okay, so I'm going to put this 3 up here, the 2 up here. So we end up with log of x cubed minus log of y squared plus log of z. So I'm going to put these together first, and this is log x cubed over y squared plus log z. And addition is really just multiplication when you condense. So we have log of x cubed over y squared times z. So how I would probably write this is log of x cubed z. think of this as like z over 1, and we're multiplying over y squared. I'm actually not going to do this second one, partly because I'm out of room and partly because it's very similar. Now some simplifying. So for these types, I would rewrite it kind of in an exponential form. So log base 7 of 7 is saying 7 to what power? Think of an equal sign here. Equals 7. So it's just 1. The other ones work similarly. Let's look at this one. So first of all, I don't know what log base 8 of 4 or what log base 8 of 16 is, but if I use properties, this is log base 8 of 4 times 16, which is log base 8 of 64. So 8 to what power equals 64? So we get 2. I'll do both of these. So here, I'm going to rewrite this as log 10 to the 1/4, because the fourth root is just the 1/4 power. Move the 1/4 out front. So we have 1/4 log 10. Again, if there's no base, it's log base 10 of 10. Or rather, if there's no base, it's a base 10. So then log base 10 of 10 is basically 10 to what power equals 10. So this is 1/4 times 1, which is 1/4. This one here, 16 over 64, but I can rewrite it. Log base 2 of 16 minus log base 2 of 64. Log base 2 of 16 is 4, because 2 to the 4th is 16. Log base 2 of 64 is 6, because 2 to the 6th is 64. 4 minus 6, -2.